Welcome back, my dear students. So let's get started with my favorite thing today, which is object-oriented approach, right? OOP approach with Python. And believe me, now you have started moving towards an intermediate, from intermediate to an advanced level. So you will see the difference now, and you will feel the difference of object-oriented now, right? And before I get started, and let me congratulate you for coming so far, for having the patience, and more important, on top of everything, having the belief in you, so that you could still manage to come this far with Python, right? And let me get quickly started with today's topic. And yeah, I have to tell you, I'll have to tell you many things about theoreticals, or I have to tell you majority of theoreticals as soon as possible, alongside practicals as well. But yeah, we think that we should get started with practicals, and as we move ahead with practicals asides, we can take care of theoreticals also, because theoreticals is also very important right here. So I'll open my spider right here. Okay, my spider is here. So let me go and open a new file, and let me save this and call this oops1. So this is going to be my first class of object-oriented programming approach, right? And let's get quickly started. Now, what do you mean by object-oriented? And now it's basically a real-world thing, right? For example, if I say dog is an object, right? And I want dog to have properties. These are properties. Dog eats, right? Dog drinks. Dog barks. A dog can eat, the dog can drink, a dog can bark, all right? These are the properties of dog. Now, in order to make dog eat, dog drink, and dog bark, I can create functions. I'll say bark. Now, this is the function. I'll say eat, so that the dog can eat, right? I can say bark. Dog can bark, right? Or now, if you want to apply more realistic approach, right, I can create a class animal. I can say now I have a class animal and it has a name, right? Now, who is the dog, right? Or maybe who? Are you supplying cat? Are you supplying dog? And so on and so forth. Now, what do you mean by object-oriented programming, right? Object-oriented means class-based programming. In a class, we have a template. It's a user-defined prototype for an object that defines the set of attributes that characterize any object of the class. Right? The attributes are data members, class variables, instance variables, methods, accessors, and many different things. What is an object? An instance of the class. Let me show you instance of the class and a class. And we start class by a keyword class in Python. The moment I say class, we start a class. I mean to start a class here, right? And let me start a class, and class requires a class name. So I will say sample. So now I call this a sample class, right? And I go inside the class, right? And it's as simple as anything, right? And this is called a simple declaration of class. Now, how do you call a class? For example, a class has a method, right? If it has two methods, for example, a single class can have two methods. So I can say define display, right? And now I just close it down right here, and I'll say print hello world, right? So now I'm printing here hello world. Now, how do you call this class? By creating an instance of the class. Now, the instance of the class is going to be created something like that: s is equal to sample, and now parenthesis, right? So this is how we create an instance of the class. Now, if I run it, now you can see, all right? And now I run it, I don't get anything. Why? Because I still have to call the function, and I use the same instance of the class, which is s. I repeat, here I create an instance of the class, right? And I use the same instance with dot to call the function, and which is the display function, like we can have now. Right? Okay, now we can see, now we're getting display takes 0 positional arguments, but 1 was given. So I don't have to give any arguments right here, all right, to my display function. All right, I'll tell you about these things later on. All right. Alright, now we have called this function, and this is how you call the function right here. We should get hello world, but yeah, we're not getting because we have some different things that we have to basically deal with, right, once we start dealing with this, right? Okay. Okay, so now since we know now a class and the declaration of a class, how do you declare a class, how do you initialize a class, right? These things are already known to you now. Now what I want to tell you are some basic techniques, right? For example, I want to display, for example, something here, right? I have to pass it as simple as anything. For example, it's a display. If it does not, let's say about, it's a simple function display, right? And it's not inside a class. Now, what is the fun of this being outside the class? Now, if I call s dot, I call this function display. Now this means it's an individual function. This function does not belong. Now you're getting hello world here, but yeah, now this function does not belong to any group, right? That means you're not creating a prototype. For example, if I create a registration form has validation wherein we have to validate data, then take the data to database, and then do many different things, right? In that matter, right, we need to have, and taking that thing into considerations, we should have a class, and that class should have the following attributes, right? For example, now what are you doing here? Let me just go ahead and create a class sample. Let me create it S-A-M-P-L-E, sample. All right, so the class name is sample, and now once I need to create, for example, if you do not have anything in the class, you can simply type a pass. Pass means the class has no body at all, so I don't require the body of class. So I'll say S is equal to sample. Now here I'm creating an instance of the class sample, so that's already known to you. You know that, right? Now what is this? There's no parenthesis, right? Why are you calling, and what are you calling here? Right, by applying the we can say by applying blank and empty parentheses, right? It is basically a constructor call. A class can have a constructor as well. Whenever you say parentheses, you're basically giving call to a constructor of the class. I repeat, to the constructor of a class. That's what it means, right? Sorry. Sorry. Extremely sorry, right? So that's what it means, right? So class can have attributes, class can have behaviors, class can have different things, right? Okay, so now what I need to do here, for example, if I have a function here, so I will say define display, right? Now this function is going to return, this function returns, or we can say this function return or prints the function prints hello world, right? So this function is going to print hello world, and now I say s dot display. Now we know two things. Now we call the function, right? We call the function with an instance of the class, right? So it's not going to display anything because you have not supplied any arguments here. So if you do not supply any arguments, you'll have to say self here. The moment you say self, now you're getting hello world. Now what this means, self is something like here a function, we can say like what do I say about this self here? It is going to be means this class, right? So self means this class, right? You're going to take instance of this class. So this self has to be in every function that is inside the class. So this has to be in every class, this self keyword right here, which means nothing but this class. You'll understand it slowly and steadily, but yeah, I'll mark it down. I'll mark down few things for you that you need to remember for your for the entire life here, right? What do you want to remember here is the following, right? We started with the object-oriented programming, and we started with the class. Class is a template. As I said, it is a template, a user-defined prototype for an object that defines a set of attributes. Okay, it's gone too much, right? So class, okay, Class a template, a user-defined prototype for an object that defines a set of. You will see that while I carry on with, I'll tell you, class is a template, a user-defined prototype. You'll not understand it, but yeah, while we carry on with practicals, you'll slowly understand. But you need to be patient, as you've been always, right? So please be patient. So defined a set of attributes right here that characterize. So I can say that characterize any object of the class, right? We can say the attributes. We can say the attributes are, we can say, data members. So you're going to understand it slowly and steadily, right? And now what is an object? Object is an instance of the class, right? So we can create as many instances as we want of a class, right? Slowly, now we have started object-oriented programming. Believe me, now initially you're not going to get more than 30-40%, right? And believe me on that. But yeah, after 5 classes of object-oriented, you'll start getting 60%, and after 10 classes, you'll start getting 80 to 90%, right? What you have to understand, it's a prototype that contains, that can fill how you can remember that by this moment in time, you have to remember that it contains functions and it can contain some member variables as well, right? How that you will come to know slowly and steadily. Object is an instance of the class. What is this S? This is an object of sample. I repeat, whenever you say S is equal to sample, we don't use new keyword here. No, like Java, we create instance with new keyword, which is not the case with Python. So Python says simple, right? Which is, sorry, not simple, sample, which is the name of the class, is equal to S. You're creating an instance of the class here. So I just mentioned here we are creating an instance of the class, or what you can say, or you could say like or an object of the class, right? So we require an object of the class. So here we can say we require an object of the class in order to access, right, all the attributes and properties, or all the attributes and functions of a class, right? So that's much better. Here we are creating an instance of the class. S is equal to sample means it's an instance of the class. You're just creating an instance. You're giving it a name. You're giving it an alias. Hey, I want to call you, right? And you use the same instance to call the function s.display. Right now you can know that this display function is an S. For example, I have class student and I have a class, we can say teacher, right? I can say hello teacher, right? We have it here, hello teacher. And now, for example, we have 2 display functions, right? And we have the instance of 2 classes. That's what happens. Or maybe you are having a chat server, you're chatting with 2 different people, so that can be the reason as well. Now you have a class teacher. I'll create an instance of class teacher. S is equal to teacher, or we can say T is equal to teacher, and I'll say S is equal to student, student, right? So now I have 2 instances. One is as that of, why do I terminate? I'm just having this bad habit of terminating everything, right? I should not terminate. For example, now what I'm trying to say, that T is equal to teacher, and it means that teacher instance has been assigned to T. Teacher is a class, its instance has been assigned to T. Student is a class and its instance has been assigned to S. And as I say s.display, I get hello teacher, right? No, I should get hello student here, right? If I call hello teacher, why do I get teacher? S.display, S is equal to student. Okay, I'm doing it wrong. So I'll say now, Okay, hello student, because you're calling student.display. Now what if I want to display teacher? I'll say t.display, same. Now you can say hello teacher. So this is the reusability and code optimization that we may require. Why do we use classes? We use it for reusability of the code, right? When we have to use the same code again and again, right? We don't have to define. For example, now I don't have to define teacher. So I'll say I have to use a single function in a single class. For example, I have class sample or have display. I have to pass parameters. So I can pass those parameters right here, for example, right? And now you can say, again, you have to remember two different things right here at this moment in time, that we have two classes. A class is a template. Class can have functions. Class can have properties. All right. Class can have member variables. I'll show you what are properties and member variables also. But yeah, I've shown you only function. All right. And this self means nothing but this class. It means this class. So this is it's a mandate for displaying or for declaring it the function of this class. Self means this class, or it means this is the function of this class. It means this. It's just a paradigm to this, or an alternate name given to this. Is that understood for you guys? Okay. Okay. Now, what is an object instance of the class? Right? As I said. Now, where is an object? T is an object of teacher class. S is an object of student class, or we can say S is an instance object of student class, and T is a teacher object of student class. And now if we have only one class, student teacher, I can have only one class. So now I don't need two instances, right? So I'll say, okay, I have only one class, that is student dash teacher. What do you want to display, right? So you have only one class, student teacher, and I create an instance which is T, and I call the display function. And it's going to work as expected, hello student. But yeah, I want to pass hello what, right? You say hello, but hello what? I'll say, yeah, I need to get a parameter known as name, and then I can concatenate that parameter. I'll say hello comma name. Now this name has to be passed, just like we pass argument to functions. You know that how we pass function arguments, so we'll use the same thing in passing arguments to the function. I'll say t dot display name. So I'll say play, right? Okay, so we don't have any name here, so name is something that I have to supply. So I'll say for example, hello student, right? I can say I'm calling the same instance, hello student. I'm printing hello student, and I can call hello teacher. So I'll get hello teacher. What time is it? Yeah, we still have a good amount of time, right? Okay, now this is how you pass parameters. Self is very important, right? Now what if I need to pass a reference as a first argument to the constructor? Now whenever I open these parentheses, now what these parentheses basically are, they are, I must tell you, a call to the constructor in that matter. So let me tell you. Right, so whenever you open these parentheses, right, since you are not calling, once you're making an instance of any class, let me get rid of this, or let me keep the valid things there, and let me just create, okay, let me get rid of all, because you if you want to take note, you can reverse the video and take note of everything that I said. All right, so for example, if I make a class, I will say class test. And let me call it, now if I have to make an instance, for example, pass is used in case you don't want to define the body of the class. You have to type pass, right? If I don't pass, type let's say, but if I say t is equal to test, I'm making an instance of the class and the object name is t. Right, and now if I just run it, you can say there is no error at all, right? Now if I don't type pass here, it's going to generate an error, expecting an indented block, right? So you're expecting an indented block right here, right? What is inside the class? You say, no, I need to pass it. There's nothing. I just define a blank class. Now, what is this parenthesis? This parenthesis actually is a call to constructor, right? Every class has a zero parameter constructor in every object-oriented programming language. Each and every class has a constructor, but it is not visible. Now, if in order to make it visible, how do you call constructor in Python? I can say, hey, def is defining. Now this is how you define init. There's no constructor, but there is something called as init, which is initialize in Python. All right. And this is something that is going to be by default called when you make an object of the class, which is not, it's not necessary that you take the instance name and call any function. No. Now this class has no function at all. This class has only one constructor, right, or initialize method, which is going to be called automatically when you make an object of the class. For example, I pass self here. Self means this class, so I will say print hello. All right. So now you can see I am getting hello. Now did I call? No, I just made an instance of the, we can say I just made an instance of the class, right? For example, now we are having the constructor, and we have let's say about even a function here. So now how do you define a function? You define a function by giving it a name. So I'll say I have a function display, right, and I will accept self as a parameter here, and I will say print, right, hello from display. Here I will say hello from constructor, right? So the moment you make an instance of the class, right, or an object of the class, you can see a zero parameter constructor is called, which is hello from constructor you're calling. Now you're getting hello from constructor. Now if you want to call the function, you have to call the function by the instance name, by the object name followed by a dot. I'll say T. Hey T, what is T? Instance of test. What is test? A class. What does it have? Functions at this time. I'll say, hey T, do you have inside you a function known as display? He says, yeah, I do have one function known as display. So now then here I am calling the function. Now you can say hello from constructor. So the constructor is called automatically when you make, or initialize function is automatically called when you initialize your test class, right? It's automatically called. And now you can see display is a function, and function is only called right when you want to explicitly call it with an instance object, right, which is T. Now what if I want to pass some parameters, right, to the constructor, right? So I will say, okay, I want to accept a constructor parameter right here, which is going to be argu argument, right? My constructor is accepting one argument, and I am printing the same argument my constructor is accepting. Alright, so now let me see if I don't give any argument, what is the result? Now you can see init missing one argument. Now you're calling test, but your test is taking, right, initialize method. Your test has initialize method, and that initialize method is by default taking one argument as, right, a parameter inside parentheses, right? So you have to supply. Now if init function is taking one argument, this self is not an argument. Keep it with every function. This means this function is big because self function means this is the class function, right? This function belongs to this class. That's why we keep this self. Now we say we have to pass this argument. So now we are making an instance T is equal to new test. Now you're passing blank parenthesis, but the parenthesis accepts one argument. So I'll say, hey, argument passed to the constructor. So now I can get it here that argument is passed to the constructor. Now you can clearly see argument passed to the constructor. Hello from display. Hello from display is coming here because you're taking the same object name and calling the display function inside the class test. And here you're passing T is equal to test. You're passing basically creating a new instance of the class, but yeah, immediately you're passing one argument here. So now if you don't pass an argument, you're going to get an error. Now in case if it is not accepting, if init function or constructor is not accepting any argument, so you don't have to pass any argument in case if it is not accepting any argument. So then you can run it just like this. I'll say hello from constructors. It's constructor. What's constructor? It's constructor, right? Alright, so now you're getting hello from. Now why is this required? Maybe you want to initialize database code. You'll get it in the near future the moment we take RDBMS, which is Relational Database Management System, and the moment we take few more things, you'll get it, right? Once we do real world application development, right? Okay, so now I had given you few definitions, right? And I told you an object is an instance of the class. A class is a template, a user-defined prototype for an object that defines a set of attributes that characterize any object in the class. I already told you. And all the classes are inherited from a base class object, right? So once you will learn inheritance, you'll come to know what is that, right? Okay. The innermost scope, I'll tell you what is an innermost scope. I'll also tell you that, don't worry. Right? Okay. I just have sore throat. It happens in Ramadan basically, Right. Okay. Alright, so let's get started with few more things right here. What if I say, okay, we have seen constructor arguments, right? We also seen constructor arguments, so that's not a problem. Yeah. So we see that now, for example, I want to say about use self. What is that self? Alright, so I want to get what that self basically is. For example, now let's say I'm not printing anything here in the constructor. So let me get rid of this display function right here. Now you understood how you call the function. So I'm not call the functions in sense it does not exist. Now what is the body here? So you'll get an indented block error. Yeah, either use a pass. Pass means do nothing. You're not going to get error. Right, but once I say that, hey, I am accepting one parameter as name here, right? In the constructor, I am expecting one parameter as name. You'll say, yeah, you have accepted one parameter as name. I'll say, hey, wait, self dot name is equal to name. So now what you do, you declare this variable here. You'll say, I'm declaring a new variable in this class, which is self dot name. All right, you're declaring a new variable here, and that variable takes. So this has a complete scope of class. I'll show you the example. You'll only get when you see an example right here. Okay. I'll say now you have created an object of the class, right? It's absolutely fine. So it's missing an argument. So I will say if and my name, I pass the name, but we're not printing the name. Now how do you print the name? I'll say t.name. Now you can say t.name is easily accessible, right? Now because you have created, right, or you can, this is basically a member variable that you are creating. It's just a member variable that you are creating here. So I'll say it's declaring, or we can say creating, or we can say variable. Is going to be variable declaration here. And now what I do, you call the function test. The moment you call the function test, or the moment you call test, you make an instance of class test. You pass one argument, that argument goes here, and you take that argument and you give it to the variable, member variable here. You're declaring a new member variable, right? So you declare member variables like this, self.name. You can name it something else, self.n. No problem. Now you're declaring a variable known as n that is taking name. So that the name you have supplied will go to self.n. For example, if I say my constructor takes f name, my constructor takes l name, my constructor takes username, my constructor takes password. For example, if in case the constructor is taking these things, so you can do this. You can say you can say self.fname is equivalent to something, right? Then you can say self.lname is equivalent to something, and then you can say self.username is equivalent to something. And what you can do, let me just a moment. All right, now, so now these are now known as they are the member variables right here that we're declaring. And now we can say self.password. So we can say, so imagine and remember that they are not declared already. They have nothing to do with these variables. You're declaring them right now. You can name them anything and pass anything. Now when I say fname is equal to this fname right here. You're passing this fname to this declared right variable. So that's why, right, you're passing lname, which is right here, to this lname. Now you can call them separately as well, right? So that is the magic of Python, that you can call them now separately, right? And you can say that username is equal to self.username is equal to this username, just to distinguish between them. So I say usrnm. So this username is right here, so I can say usrnm, or we can say pswrd as password, right? And now you can say, okay, now whenever you call the function, now you know that the constructor, which is this initialization function, its constructor is nothing but an initialization function in our case, is accepting how many parameters? Self is not a parameter. This 1, 2, 3, it's accepting 4 parameters. Now if it is accepting 4 parameters, right, you have to pass 4 parameters, or we don't say parameters but arguments. How many arguments does the constructor accept here? 1, 2, 3 and 4, right? Okay, now I'll pass first name is this last name is this, and last name is Khan, and let me pass username is FAHIMKHAN, and password is PSSWRD, right? So now I passed all the parameters, right? Now, okay, now it's absolutely fine. 1, 2, 3 and 4 parameters. 1, 2, 3 and 4 parameters, right? And now what you are doing here, you are declaring variables, right? Okay, all right. So let me go ahead and run it. Yeah, it's absolutely fine. Now you can say I want t dot. Now you can say that's why I told you to use spider with, because of this Intellisense. Now you say t. T is what? Again, it's an object, or we can say t is an instance of class test, right? So you say t is equal to test. The moment you call test, by default this init function or this constructor is going to be called, right? Now if you, at the time when you make an object of the class, I repeat, at the time when you are making an object of the class or an instance of the class, right, if the arguments of the constructor does not match as that of the instance, right, so it is going to generate an error. For example, if I don't pass any arguments here, so it's going to generate an error. Now if I pass, I can say I need to get t dot f name. I'm now calling the member variables directly one by one, right? You passed at the same time, but you can call now one by one. I can say that, hey, I need to get t dot f name, or I need to print t dot f name. T is an instance of test and f name is a member variable here. Now you're getting Fahim, right? You can now say, hey, wait a second, I need to print t dot l name as well. So let's hit enter. L name is not there. Okay, I just added one more C. L name, you're getting now Fahim Khan, right? If you want them in a single line, you can either use and is equal to this, or you can, and is equal to this means you are not ending this line. So if you're not ending this line, that means this line is going to come in line with this line, right? Or you can do this f name, and then you can say L name. So you can print both of them, L name and f name, which is t dot l name and t dot f name. You're getting Fahim Khan, right? And this is how you pass values to the constructor, right? So now we don't call this as constructor. Let me be very frank. We don't call this as constructor in real Python. It's something like init. Init is like initialize, right? Because if you see other programming languages, like C hash is there, Java is there, C++ is there, and maybe PHP is there, and different languages. So the name of the class is as same as the name of the constructor, right? But here it is different, init, which means initialization. Which means this is the first thing to be automatically called. You don't have to call it. This is the first thing which is going to be automatically called whenever you make an instance of the class, right? So the body here is going to be automatically called. For example, if I don't have any constructor, now in case you'll say, sir, if I don't have any constructor right here, right, I'll say pass. Now still I make an instance of this class. So now when I make an instance of the class, why do I pass parentheses? Yeah, that is the call to the default initialization method. Whenever you make an instance of this class test, you have to agree on one thing, that the class test is initialized irrespective of you having the init method defined internally explicitly or not, but still you are initializing the test. So a default zero parameter constructor is called whenever you call the class. In our case, a default zero parameter init, right? So I'll say this. Right, by default, this is being put inside the constructor automatically, right? What do you call this? Automatically, right? And I'll have to indent it well. Okay, right? Okay, and it takes 0 arguments. It does not take any arguments. Okay, let me get my back. Does not take any arguments. So now what is the problem here when it does not take any arguments? Okay, it does not take any arguments, so we'll have to still keep self here, right? I forgot. Now what I have to do here, that I said t is equal to new test. Now it doesn't matter whether you have this init being defined inside the class or this init is not being defined inside the class. It is going to be automatically used by the interpreter, right? Interpreter is automatically going to put a default constructor here at the time when you run it, right? So this is a call to the default constructor, which is 0 parameter constructor, right? So let me repeat, what did we learn today? Class is a prototype, right? A class can have member variables. How do you define member variables of a class? I will say class test, right? And I can define member variables like this: self, right? I can say self dot name is equivalent to something, right? And self dot address is equivalent to something, and I'll say self dot phone number is equivalent to something, right? So this is what we can do inside a class, and this class can either have a constructor or it can have basically a okay, just a moment, right? So this cannot be now once you are declaring self.name, self.address and self.phone, it is going to throw an exception. Why? Because where are you initializing them? You cannot initialize them directly inside a class. Then where do you initialize them? I initialize them inside a 0 parameter constructor. Doesn't matter, you can initialize them inside a 0 parameter constructor. I can say init, which is a 0 parameter constructor. So I'll say define double underscore init, and I'll pass self here, right? And now I'll indent them. Now you can see they are being declared and defined. They're not only declared but are initialized with blank strings, right? Here. So now I can make an instance of the class. I can say t is equivalent to new test, and I can say, hey, t dot name, or we can say t let me see this, t dot name is equivalent to name, and I can say t dot address is equivalent to address. Now we are accessing the member variables. Now they are the member t dot name, t dot address. Now we have to access them because everything inside the class will be accessed by the instance name or the object name. Here we are defining a class. I repeat, what are we doing? We are defining a class, and here what we are doing, we are making an object of the class, instance of the class, and with the help of that instance we're calling member variables of the class. These are called as member variables of the class. I can say t dot let's say about phone is equivalent to 94194412344. Now I can run it, right? It runs absolutely fine. Now what if my class has another thing, right? My class has a function display. Now let's see, my class has a function display also. Not only it has a constructor, but it also has a function display. So this display function is going to print for me, right? It is going to print for me a formatted string, right? A formatted string which is going to be name, or we can say, and let's say about the first thing, that is going to be name. So I'll use self dot name, right? So let me run it. Yeah, absolutely right. So I can use self dot name. So why, just a moment, if I call this t dot display, so let me call this t dot display, and see, I have to just call name then, right? Okay, print, just a moment, why are we getting this error right here? So yeah, because this is the member variable that we're trying to declare. It should not throw any error right here. Display takes 0 positional argument. Yeah, I just forget this self. You have to mention self with every single thing right here. Yeah, name is not defined. I'll say now self dot name, right? Now if I say print, yeah, we're getting print. Now we can say this is a display function, right? I'll say self dot name, right, lives in, and now I can say self dot address, right? Self dot name lives in self dot address, and his contact is, and then I will use the same here, self dot contact, right? So now this self should be with, or we can say that each and every function should carry this self with itself, right? So now I say I'm creating an object or instance of t, that t is an object name of test, test is a class, and with the help of the test I fill up the number variables, which is name, address and phone, right? Then I need to display them. I say t dot display. The moment I call t dot display, right, I have an error. What is test object has no attribute contact, right? Okay, it's not contact, it is phone, and his contact number is self dot phone, right? Alright, so let me run it. Okay, sorry, let me run it again. Now we are getting Fahim lives in Srinagar and his contact is this, right? So now this is how your display function works. This is what your display function does, right? Now you can pass another parameter right here. Now see the magic of class, see the reusability, see the optimization, and see the usability. I say t1 is the another object name for test. I'll say t1.name, t1.name, t1. So let me make it Naveed, and t1.address is, for example, Karan Nagar, right? And the number is 908765655, right? And now I'm passing all the things. Now I will call the same class but with a different object name. I'm creating another. The moment I say t1 is equal to test, a different memory is allocated and we are getting a different instance of this class, right? Now you can see Fahim lives in Srinagar and his contact number is this. Naveed lives in Karanagar and his. Now you can call as many times as you want. That is the magic of class. This is how your class works, right? And this is the magic of object-oriented programming, that you are taking member variables you are calling member variables so that they take values from you, right? And now you can just make it more sophisticated. You'll say, hey, why don't I pass it to the constructor, which is called as constructor overloading? That you can do as well. And you can now have luxury of doing anything. You have the luxury of reusing anything because now you started doing object-oriented programming, right? So is that understood? And you are going to love this object-oriented programming. For example, you say, no, I don't want to supply to member variables. I want to supply through the constructor, or we can say to the init method, right? So you can supply it here. You can say, hey, I want to supply it here. So I'll say, okay, don't worry, self.name is equal to name. So and then I'll use this name here, right? As you have seen earlier. But yeah, you'll understand it slowly. First class of object-oriented is going to be like 60%, 50% understood. But yeah, the moment and the more we get used to it, the more we get familiar to this, the more we practice this, the more we are going to get the know-how or the technical know-how of the things, right? And it's going to be a real fun. Believe me. And if you have come so far and you've shown a lot of patience, right? Okay. Yeah, so you're shown a lot of patience. That doesn't mean that you are lesser than any other average student. You're not now average students. You're not average students now. You are better students now, right? So better students are meant to learn better things, right? So that's what you are learning. You're learning more better things now, and we are going to show you few more tricks also. I hope you have understood this part, right? Okay. All right. So now let me go and tell you the scope. The innermost scope, which is searched first, contains a local name, right? So the scope here is within the class, right? Now if you want to call this scope, you have to call with the object of the class, which is t dot name, t dot, right? So whenever whatever is inside the class, if you want to call anything inside the class, you call it with an object of the class, right? So that is the basic real example, right? That's what we call as real example, right? And what else? Yeah, that's already seen. Constructor is already seen, or initialization is already seen. Okay, all right. And we have seen how do we pass parameters as well, right? And now let us say adding a method, right? Function is a function without a class, but inside a class it's a method. Now, what is the difference between? Let me delete this. What is the difference between? Let me just show you. What is a difference, or we can say difference. What's the difference between function and method? Right? It's a very simple, right? Whenever we call, right, a function with an object, right, name, or with an object, right, for example, right, we can say obj.display, right? So now this is not called as function, this is called as method, right? Whenever we call a function with an object, for example, obj.display is called as method, right? And or we can say function is a function without a class, but inside classes it is method. So inside classes it is methods, right? So whenever you call anything, any function which is inside the method, that's not a function, that is the method of that class, right? That's called as method of the class, right? And we can have, what do we have here? I'll just repeat it here. For example, if I go with class computer, I create this class computer, right? So now what do you expect here? Here we can have attributes, as I said here. You can expect attributes, right? And that attributes are nothing but variables, right? Attributes which are nothing but variables. And what do you expect here? You expect behavior, and behavior is nothing but methods. Methods, you know, that are also known as functions, right? Functions become methods inside the classes, right? And that is basically understood, right? So now let me show you some basic for usage. So I'll say class. I have a class, right? So I have a class computer, right? And now what I do with this class computer, I say I am defining a function config right here, and I'll just take it self. That means it is a self, means this function belongs to the class. Now this self makes the function as method here in Python only, right? But in every other programming language, if a function is declared inside a class, it becomes method. But here, this makes this method, right? This self. So I can say print, I have a computer which is Core i7, right? It is Core i7, and it has a 16 GB of RAM, and it has 2 terabyte of SSD memory. Now this is config. Now the computer can have config, the computer can have different things. If I say I have to call this config, I will say comput, a computer, right? I'll say is equal to new of computer. Now this is called as making instance of the class. I can say print the method. I can print the method. I can say c dot config. Now this is the method that's being printed. This is the call to method. Now you're printing i7 16 GB 2 DB and 2G 2 TB SSD, right? So this is what you're printing here, right? So this is called as behind the scene common is passed, or we can say this C is passed as a parameter to the method config, right? What are you passing to this method config? This C. Now this is config. Now what is this self doing? This self is actually here to take this object C. Now what this object is, it's actually class. That's why we say self. It's basically nothing, it's just the class name. You'll understand it slowly and steadily. But yeah, behind the scenes, I'm telling you, behind the scenes, com1 is part of this C basically. If I say computer com1 here, and I'll say com1. So now behind the scenes, com1 is an instance of computer class, right? You say yes, and I say com1, calling the instance, and with the help of instance, I call this config method. Now what is the self doing? Behind the scenes, an hidden argument is passed here in the config, which is this com1. So this com1 can be here also. That's why we're taking it. But yeah, self actually means this class, right? You can also do this. For example, I can say, if you want to make the instance of this class as well, so I can do this as well. Instead of this, I can say, hey, I have a class known as computer. Now you can say this is the computer class. Now how do you get Intellisense? For example, your computer is not getting Intellisense. I'll show you how to get Intellisense in the on-screen keyboard. For example, I want to get Intellisense. I will write C. Alright, I will write here. I'll take the mouse here and I'll write C. Right? Now you want to get Intellisense, hold down the control key. Keep control key pressed and hit the space bar. Now you can see you are getting Intellisense. That is control space bar. And now you can say computer, and then I can go ahead and say, right, computer dot. Now you can say it's showing config, right? Computer dot config. Now you know control plus spacebar will let you get the Intellisense on, right? And now you can pass this here. You can clearly see, okay? So you can say computer.config, right? And now if you call it directly, you are not going to get it because it is accepting, missing one required positional argument. And that is the case right here. You can say com1. And what is this com1? Right? It is nothing. Now you can create an instance. You can say com1 is equal to computer. Now you have this right here. Now you are getting i7 16 GB 2 TB and you are getting SSD, right? Because what are you doing? You are saying either you can say com1 dot config. It's one and the same thing. You will get the same. You're taking the instance name to call the function, absolutely no problem, and you're calling it here. Or I said behind the scenes, you're passing this comma. Now you can see computer dot config, and I pass this com1, right? So that is why the self is here, so that it can take the instance, right? This is what is behind the scenes. You don't have to do that. You just have to target on this. I was just showing you what is happening behind the scenes. So this is your class, this is your method, and this is your instance, and this is your call, right? So I hope you have understood. Those who have just understood 60-70%, right, 60-70% is marginally very good. And in the concurrent classes, when we move ahead with dependencies, object dependencies, size allocations, constructors, destructors, and many different things, when we move ahead with that, you will be inshallah able to get it more we can say in a more better way, and you will be able to get completely and theoretically and thoroughly. What you need to be patient, and second, consistent, and third, believe in yourself. Believe in yourself, be patient and be consistent, and do practice very hard, and you'll be inshallah a good developer. And now the time has come wherein we can think of making you or exposing you to software development, right? The time has now come near. I wish you all the best and also congratulate you. Wish you good luck for this session and the session coming in the near future as well. Bye bye. Take care.